So B is an offset, A is in a gain. So sometimes the open hole gamma ray with bigger number. So I need to put A maybe less than 1. So for example, I just put 0.5. So you can see if I click OK, so you can see it's moving. Yeah, it's decreasing. So if I put it back, then it's coming back normal. Yeah, so you can adjust this one in order to have like the peak is almost similar, right? Usually the open hole camera is a lot bigger. Okay, so and then I move back to upgrade. I click highlight. So at the top, more or less okay. So I'll show you how to do the stretch. Yeah. So the peak is that is a bit okay. Yeah. So click on stretch and there is multi-point correlation. Multi-point correlation. So I just move the window to the right. So you see the different colors now. So the reference still black. So I need to put the fixed point. So for example, I like to put the fixed point here. So it's cross. So it's fixed point. Then I need to make the second point to the third point. Yeah? For example, I like to put this one to be here. So the second to the third. If you want to delete, undo, right click. So for example, I like to have this peak to that one. Yeah. So will be the black one. So the highlight is the previous one before the shifting or stretch. So you do that one and then you do sequentially from top to bottom. And then number 3 to third, number 2 to third, and then number 4 to fifth. So something like this. So the black one is the one that has been shifted. And if you look at the bottom, I need to move a bit up. Click on that one and then it move up a bit, something like this. And for example, this one I like to move up a bit. So you can stretch in, stretch out, your depend on you. Then you might have something like this. And if you're happy with this one, just click OK.
If we click OK, can we undo?
Yes.
Yes.
So we want to undo, click on the I button, click on the edit option. Oh, that's the one that we have. This is the first fixed point, the cross.
Mm-hmm.
Second point to third point, fourth point to fifth, sixth to seventh. So if you want to delete one by one, you just delete the column or you delete all. Reset will be reset. So you might have stretch in, stretch out. Yeah, depend. But you need to go in one direction. If you start from top, you go to top. If you start from bottom, going. You can do the other way. This is quite handy if you have very long interval.
So stretch I use for multiple points
Yes.
on the same pass.
It is.
Okay. So depth shift I can only do once.
Yes, because it's a block shape.
Just shifting all together. Right.
Yes, shifting. Yeah, the shift is all data in one pass. They will be shifted or stretched.
Okay.
The shift is just like a block shape. So shift by 1 meter, so everything moves down 1 meter. Stretch is just stretching different point.
Okay.
Yeah.
So do we need to do like both or
Yes.
can choose?
Usually I need to put shift first to make it on depth at one place. And then I like to do stretching if it is not correct. So first do the block shift.
Okay.
If it doesn't work, do the shift. I mean do the stretch. But yes, usually I do the shift first.
Okay.
So how accurate is your clock?
Mm.
Yeah. because it can be take a long time to do this. So if you want to be quick, I mean, just especially depend if you have very thin layers, then you might be very precise on the certain depths. Yes, you do it quite a lot of stretching. So yeah, you can go back by this one. So otherwise, just click OK.
So when I do the for gamma ray, everything else will be like
Yes,
that.
in that box.
Okay.
So that's fine. Then I go to the done one. Yeah, the one I think I need to do some stretching. At the top seems okay, but it's stretching. So I'll show you from the bottom to top. So I need to go to grab sheet, the down one, and just put at the bottom part, click on there. Now I put the bottom on that, on down one. Then I like to go some stretch here, multi-point. So I'm starting from the bottom now. So for example, I like put that one to be here, that one to be there. Yeah, so the black, look at the black to gray. There, there. If you're happy with your practice. So you can have stretch from bottom or you can have stretch from the top. Don't do seems okay, don't do seems okay. Yeah. So if you see all of them, there's and show only active bus. I click on that, so I show it.
What does it mean by stretch by zone?
This one.
Ah.
Yeah. Before we have a multi-point, we have a zone stretch. So you do zone by zone. It's the same, almost similar, but I prefer this multi-point because it's more interactive, I would say.
Okay.
Because the zone stretch is something like this one here. I do that one, and I can stretching in and stretching out on that zone. And then you've done that one, and then you click another one. So this one time it's time. So one stretch every time. So it's better use multi-point so you can do all at once. Yeah. Okay. This is just per zone, but multi-point you do all zones. On the full lock range, uh, oh, okay. I don't know that page, this one. I can undo. Yeah, remember you can undo. If you done something you want to undo, you just undo button. How many undo you can do? You can click on the settings. Alright, I think it's 5 or there is nothing on the settings. I think you can do 5 times backwards.
More than enough. 5 times.
More than enough, yeah?
Yeah.
Okay, so yeah, more or less like that. You can do also with the CCL, set up gamma ray, and you want to make the stretch based on CCL. It's your call. Then I can show back all the, I click home button and show all the interval in one page here. Okay, so seems to be okay, yeah? More or less. So what we can see here, I do have pressure. I like to make TPDC, right? So how do I make TPDC? I can go to the browser and I go to one of the paths. For example, up one, and just click pressure, and you can see the browser icon on the left is the same with the one on the top on the ribbon in Edit QAQC. So either you choose that one or that one is similar. So you have F prime derivative, you have F prime derivative as well in the ribbon at the top. So you click on that one, make it every 2 meter. So I use for all, so I click on log data. So I will be doing derivation of all 6 passes, pressure data only, and I click OK. Then I will have DBDC and DBDC core.
Core.
You know what's the difference?
Corrected. Related.
DBDC is over MD, DBDC core is over DBD. So we like to have DBDC core.
Mm.
So I can put DBDC core, oh, it's already there. I can take out DBDC off. DBDC core is connected to deviation, but not for friction. Okay, so I can put DBDC core next to CWHR. Here you might see. You can see the, if you put the arrow, or not the cursor, at one point, you can see on the bottom left, you see the depth and the number.
Mm.
Yeah. So it's 4.9. And it shows on the tone 3 because I'm pointing tone 3 at the top. So I'm pointing tone 3, the curve is one. If you want to see all the curve at one depth, you click on this. If you deal with multi-prop, it might be quite helpful. Yeah, so you might see some changes if you see the tabs there. So just to see the consistency between the density and capacitance examples. And in the top is the gas density, bottom is water density. Okay? So if I click close, that's it. So then we like to make sense of the data. Camera looks okay. The perforation in front of the sandstone, so makes sense. Nowadays, we perforate shell plus shell oil, so sometimes you have perforation in the shell. CCL looks okay. CFS and ILS, so you might see it. The ILS at the top looks, I mean, you have some RPS, even though it's not very good. I can go like this to make it wider. Yeah. Then, yeah, you can see some of the numbers. And remember yesterday in the sum in no-flow zones, the sequence or the separation between RPS and cable speed should be similar. So you just look at the tone pass. So yeah, so this red, green, blue, red, green, blue, red, green, blue, red, green, blue. So the sequence is okay. If you look at only the up pass, that's okay as well. Even though the number not that good, but at least the sequence is okay, except in this one, in the middle. So we have some overlay between different speed. So the data is not that good in the middle. So that's the one. And now from the ILS, you might see that the top one is producing into the bottom one. Agree. So it's a downward cross flow. Remember, if we put the station, should be in between the blue, right? if you put the station, it should be in between those blue lines. Because the zero RPS, zero RPS, zero capital speed here. Zero capital speed should be in between this plus and minus capital speed. So you see this one, if you look at the number, it's minus something, so it's downward flow. So if your spinner is in the middle there, you can see the spinner to flow from above. Yeah, from above, it means that the top is producing downward into the bottom zone. Yeah. The next one is, if you look at the CFSR, is if you look at the CFSR, I like to make it smaller, this one, and I can make this one bigger. The CFSR at the bottom looks good, yeah, in the water, but at the top is no RPS. Any reason on this one? The tool fail? Only in the gas, but in between the zone, the RPS is working. So you have some good RPS in between the zone, but at the top is zero.
Threshold.
Yes, threshold. Why is threshold? How big is the
Yes.
threshold?
Guess so.
Yeah, if you look at the data, for example, I just look at DON one. Just look at this. So when you do the DON one, when your cable speed is 35 meter per minute, it's reading zero. But then at some depth, start to read something, it's negative. And then when the cable, when it goes back to zero, even though you run at 35 kilometers. In the water, that's fine. 35 meter per minute, you have RPS. So in the gas, when you run at 35 meter per minute, you still not overcome your threshold. So that's why it's still zero. But when your cable speed and your rate of fluid is higher than 35, start to read something. Yeah, you read something, and then if it is less than 35, it just straight back to zero. In the water, the threshold is less than 35. So that's why when you run in zero fluid, but 35 meter per minute of cable, it reaches some RPS. So the threshold in water is less than 35. Threshold in the gas is higher than 35. And if you go back to number 2, yeah, the speed is 25, of course. 35 is 0, 25 of course is 0. But in the water, 25 is still okay. So the water threshold is less than 25. This is 25, 27, 25. But in the gas is higher than 25. Because in the previous one is higher than 35. So of course, if it is below 35, then it's still 0. But on the DON trade, we have less, 13 of course is 0, because it's less than 35. But in the water, even with 15, you have the RPS 1.6 something. So the threshold in water should be less than 15. The threshold in gas should be higher, or at least 35 for CFSR. Again, this is just for the training. Usually you have a better data on CFS other than ILS. That's why you can see that his sharp change there. So it's just flip between 0 and some number. Actually, the response should be like this. It's a gradual. So the perforation is taken fluid one by one, I mean step by step, not like sudden like this. This is because of the threshold. So we don't use that one and that sharp change at one depth. Yeah. It should be like gradual over here, right? But this one is also the gradual is happening, but between its and depth is just flat. So you can see the effect of the threshold in this case on the CFSR. So first we like to use ILS to calculate the rate, and we can also do the second interpretation using CFS, or we can use both. Yeah, we can use both to confirm ILS and CFS. So both we have a slope for ILS and slope for CFS. Okay, so what we do next for the QAQC, you can see the threshold in CFS is not good, but ILS more or less small threshold, where the data is very noisy. So we try to see what we can see from this noisy data of ILS.